So thanks. There were some great talks about the cloud and what's happening in the hyperscale networks. If folks have questions, the microphones are open. Feel free to line up here. I know it's the afternoon. Everybody had lunch, but...
Is this time for Plan B, the song and dance routine?
Yes.
No.
Otherwise, we'll sing that. So perfect. Please go ahead.
Jan Villeren, Bloomberg. I have a question in regards to the build versus buy continuum. Well, and it actually relates to other presentations as well. So this isn't the first time we've tried to shift the slope of the build versus buy. I mean, we've tried this in the 90s. We've had big telecom vendors make their own equipment, and somehow it died down in the 2000s. What makes everyone think we can succeed this time?
Well, I think there are a bunch of very positive data points in this space. Google's making it work, Amazon's making it work, Microsoft's making it work. I'd like to think Facebook's making it work. Also, I would say the big change is not technical but cultural, meaning that I'm trying to remember, what was the telco backplane standard that they tried to make? Like, that thing was an interesting bit of technology that never changed any of the fundamental cultures of telcos, which is to say, nobody was actually building stuff, they were just specifying things, which is not at all what I'm talking about. So, you're right, I mean, a bunch of people have tried in this space and failed, but I do think this attempt is different.
Yeah,
people want to weigh in on that.
Technology now is different than it was before. We can have available technology, which is the complicated and expensive one to build, like the ASICs, available for us today, multiple sources with different feature sets, etc. And all we build on top of that. When you build on top of that, it's much, much easier to adopt and create an ecosystem that will be there. And there's much more openness nowadays than used to be 10, 15 years ago to write open source code. The open source community for open source code is probably 10 times to 50 times bigger than what used to be 15 years ago. So that will give you an opportunity to actually have a software and a hardware packages that will be completely open and enable you to be independent from the OEM lockdown.
So let me slightly expand that question. So there's always a little bit of a pendulum of do-it-yourself versus taking off the shelf, right? Am I hearing correctly that both of you are saying at the moment the pendulum is still moving more towards do-it-yourself?
I guess I would say yes for the right class of people, which is to say,
of course, yeah.
Well, I mean, I would put it differently, which is to say, historically the pendulum has been chained to the wall on the far side, and now the chain is kind of breaking down. Now, does that mean it's going to move for a lot of people? And I hope what people took from my talk was, for a lot of companies, it doesn't change anything. But at least for those who want to look at this, and there are some benefits to it, it's now at least possible.
And I think the only thing I would add is, that's not necessarily only true of hardware, it's true of even software. So companies such as Google and Facebook 10 years back built a lot of things in-house. And now there's this huge trend towards actually bringing open source in Google as well as taking open source out. So if you looked at Istio, we are using a proxy from Lyft. And so that's a huge mindset change. And I think one of the really good slides was the one Rob put there, which is you have to figure out where you fit. And you can start anywhere, and then you can test and then see where you want to fit, and then what benefits you get out of it. So I think it's happening across the stack.
Cool.
Super.
Yeah, hi. I have a question along the same lines around the build versus buy thing. Actually, pretty good talk. So, question is for LinkedIn. How do you justify your management to build things when? And the reason for my question is the content-wise, LinkedIn is not like top 2 or 3, correct? And being part of Microsoft, like the management can just say, hey, just move to Azure, correct? And or the third option is you can go to any commodity like HP or Dell and say, hey, give me complete commodity solutions. So how do you justify all these like hardware and software projects for building data center infrastructure at LinkedIn? So just curious.
Yeah, you had like 4 questions in there. I'll try and address them one by one. So how do we justify to our management? We justify to our management on the hardware side that we can do things better. And if we are more optimized on cost and we're more optimized on mostly time to deploy from request, that there is a buy-in from management to do that and accept that. Second question is why not go to the cloud, right? So we have Microsoft as our mothership, and we can move everything to Azure. It's not that simple. So the LinkedIn application is very complex. You don't see it when you actually approach the LinkedIn.com interface, but behind it there's a very significant and complex set of applications, over 1,000 applications running in the background to do that, and each and every one of them has its own requirements from a latency, performance, compute capability, etc. So transitioning it into any cloud environment, doesn't matter if it's Azure or anything else, is extremely complicated. And it's a project which we can take a look at, but it's much longer cycle for us than actually enhancing the experience for our users. Our goal is actually to make the user experience at LinkedIn.com the best we can, right? And we're willing to pay for that in data center and in hardware and in software management tools to make that experience the best in the world. So that's how we justify it. We're going to make the experience for the users to be the best in the world we can.
Please.
Thank you for the great presentations. I have a question related to, Rob, what you presented on the continuum of make versus buy. You did mention Amazon. They have gone all the way to actually building their own silicon. And based on some of the recent presentations publicly, they've talked about basically a smart NIC product that they're building themselves. We've also heard Microsoft publicly talk about their own smart NIC. So this whole continuum of building the entire thing, are these outlier scenarios, or this is a trend that we'd see more and more?
So let me answer that two ways. One is I think that there are certain industries that have started a flywheel of innovations in infrastructure, and they have business models which are possibly unique to them, or at least hard to replicate, that encourage that flywheel to spin faster. And so for those companies, I think the sky is the limit in terms of what they take over. And you know, Facebook is publicly building satellites and crazy stuff like that, right? But separate out the companies where infrastructure is a flywheel that drives their business. That's where I think things are honestly much more interesting. And I think it is harder to justify, but also I can imagine it still being possible. Particularly, in my mind, there's a continuum of R&D cost versus benefit, and the extreme of that is building your own packet processing ASIC. But a smart NIC is maybe a little bit better, and things like that. And so it'd be interesting to see how that breaks out. I don't even want to make a call at this point.
Thank you.
Other people want to weigh in?
One more comment on make versus buy, and I think you've left something out of the continuum. There's make, there's buy, and there's the middle ground where you assemble. And what we're seeing a lot of folks doing on networking, certainly among our client base, is disaggregation of hardware and software so that the software winds up being fit for purpose. And you don't get quite the benefit of writing your own code, but it's a whole lot less overhead. Probably gets you 90% of the way there with 10% of the risk. And within our client base, we've seen it go from dozens to now hundreds and heading toward thousands. So I think there's an important, meaningful step you can take that's not quite as big as yours, but certainly very useful.
And apologies, due to bad time management, I kind of blew past my point about open source, where there's build, there's buy, and in the middle there's what I was calling it tweak. And I think that kind of speaks to what you're saying.
Yeah, good pitch, thanks.
I have a question about consumption of open source internally at hyperscale, where many of the companies that you're representing have some kind of criticism directed towards you for consuming open source more than contributing back. And then some flagship projects that are great contributions. And so my question is, do you see this as a concern internally? And is it an opportunistic moment in time where if there's not a stronger focus on taking those core contributions and delivering them back to the community, do we kind of slowly fragment and lose the value of initially the open source that you're consuming?
I've been speaking all the time.
Who wants to take that one?
I'm happy to take it, but I've been speaking all the time. So
No, I'm totally fine with that. But yeah, no, I think I would not entirely say I agree with what you're saying. So what I mean by that is if I look at, and specifically I'm going to talk about the networking open source projects, I think it has been found that the moment we open source our projects, we get a lot more value out of it. And so if you think of some of the projects, the ones that I'm familiar with, one is Kubernetes. So Google actually created Borg to actually manage its own in-house like deployments and so on and so forth. And doing it at scale was really hard. And that is how Borg was born. And now that is Kubernetes. I know a lot of companies are involved in that, a lot of traction in the open source community. But anytime we pull, so we have something called GKE, which is like the managed version of Kubernetes and Google Cloud. Anytime we have to put a feature first, it first goes in Kubernetes and then gets pulled in-house. This gRPC, which was open, so if people here who've used protobufs, like you're probably familiar with gRPC. Recently, like the most recent one is TensorFlow, which is machine learning for everybody. And all of the other public clouds are running each of these. Like recently, Amazon joined CNCF. So I think, in fact, I would say the reverse. Like we are open sourcing as much as we can, because even for Google itself, there are tremendous benefits. At the same time, we don't want to get stuck in like not built in-house, so we won't use it syndrome, and which is what you see in Istio. Like when we saw Envoy, which was an excellent proxy, and it provides some really great functionalities in terms of like the load balancing or things such as circuit breaking, monitoring, and so on. There was no reason not to use it. So that came in-house, and then when we contribute to Istio, that goes back to the community. So I think, in fact, there is a lot of back and forth in open source, and at least from my perspective in Google Cloud, that is one of the big differentiators for us. So it's in our best interest to actually contribute to open source as much as we can, and then also leverage open source back. I don't know.
Yeah, please.
So I actually happen to agree with you. Yeah, I think it's a hard trade-off, right? Like I think it's a very active conversation in pretty much any big company. I think there's a set of things where it's much more powerful when you bring it out to open and we have multiple contributors, and there's a class of things where we definitely want to do that, and then there's a class of things where you really kind of want to differentiate, if you will, for commercial reasons, and it's a hard trade-off. I do think the momentum is shifting slowly towards open source, being more open to open source. But I don't think there's a perfect solution. I think it's always going to be a hard trade-off.
I guess, take this with a grain of salt. I'm not able to represent Facebook on this. I haven't been there that long. But, at least, my take on it is there's almost two sides of it. So for existing projects that are external, I think there's actually been a strong and do the right thing approach of pushing back, even just for pure engineering reasons. If I make a modification to a project, I need to upstream it so that I do less work when I get the next version, right? And so that's kind of one camp. But then the other camp is for a new project that I have created that I open source. I think Facebook's been pretty good about that, but with the caveat that just because I've open sourced the code doesn't mean I've created a functional product. I think a lot of the industry gets hung up on a open source project versus a product, which is in my mind the hard difference is. A project is something that worked for me, kind of, sort of, with enough asterisks that I'm running. And a product is somebody has smoothed off all the sharp edges that it's likely to work for other people. And this is where I was talking about Linux 1996. I think that was a project, and companies like Red Hat and others took a lot of work and actually made it a product. And the question is it going to be in the interest of folks up on this panel to take projects, which I think, to your point, they've done a good job of throwing over the wall and turn them into products. And that's less clear, but at least at an engineering level, case in point, I'm trying to do exactly that with the FBOSS project.
Yeah.
But the reality is that it's pretty rough right now.
I'll add to that. For LinkedIn perspective, we look at open source as strategic to us. We have about 120 projects which are on the open source that we drive and own. Some of the big ones that most of you probably heard or use are Kafka, for example, which was driven all the way through. It was not just let go. The issue that we've seen with open source projects where we get a lot of involvement is sometimes you get contamination. So what happens is that a lot of people start to contribute, and some of the code that's being contributed is actually not good. So we spend a lot of time actually going and taking, if we actually go back to the branch every time, taking the code back and cleaning it up. It takes quite a bit of time for us. So we will own projects specifically and bring them to the point that everybody can use them if we believe there's critical mass of people which are willing to do that, and not just people who write code and throw it over the fence and then run away, which is sometimes the case in some of the projects that we have. But we have very significant projects that we participate in. We participate in Sonic with Microsoft on driving a network operating system. We're contributing, like I said, over 120 projects in software, and Open19 is going to be the first hardware project that we're going to contribute, and we're going to contribute it in a way where people can replicate it. And that's the key for doing this. And it goes back to product versus project. If you contribute to the level that somebody can take it and implement it and use it in their environment, that's the way it's supposed to be contributed. Just putting pieces of code, especially from people which are large like us, should not be done.
And I think I wanted to recap like what all of them were saying, because they brought up three really important points. One is that typically, if you're somebody like Google or Facebook, when you put a project out there, you are pretty much putting a set of people to at least handhold in the initial days. And to Yuval's point, like that, it also ensures integrity, but then there are folks like Red Hat who are actually making these projects successful in this first place. So none of that goes away. I think the idea is that you put out, you take your projects that you can actually open source. We work with the community, but you do have people who ensure that the quality is consistent. The code quality is actually such that it does not get contaminated. And then you have other folks like Red Hat and so on, who will take and help you put it in your own deployments. And lastly, the public cloud providers themselves will offer managed versions of it. Like we have GK for Kubernetes, there is hosted TensorFlow and so on. So I think all of these models are required to make the product successful, but you do have to put out the projects and you have to ensure that they actually go out as products. So all of it is needed.
Thank you for the comments. I have one other question, which is a complete digression, if you'd indulge me for a moment.
Speak quickly, and then the person after you, I think it's the last question.
Okay. I missed the very beginning of your talk, Robin. Before lunch, you pitched it. 100 gig interfaces, you get like 2 nanosecond intergap between packets. My belief is we're starting to run out of space in software, and we're going to shift back to hardware. I'm interested in your views on the hyperscale space.
This I think is a very fundamental pendulum thing that people put more and more into hardware until they realize that yes, the performance you're getting is great, but it's coming at the cost of generality. Things will swing more to software. I do think at a data plane level, which is very different from what we've been talking about, we have been a little bit more on the software, on the hardware side, and that's why I'm excited to see things like eBPDF and some of the TPDK and the kind of the high-speed packet formatting things. I don't think that actually replaces the need for the speeds and feed fast ASICs, but it's nice to have that duality.
Perfect. Last question.
Question for you, Yuval. The Open19 project. Yeah. You said the one SKU switch. How far are you from needing to support multiple types of switches? And a second follow-up question is, how do you interconnect racks? Any thoughts on that?
Yeah. Okay. So the single SKU switch is a network architecture that we put in our data centers. It's not necessarily associated directly with Open19. Open19 as the first building block of the top of rack connecting to that design. That design is clear, and we talk about this all the time. It's a 5-stage standard clause, but it's a standard clause which is built out of only one RU top of rack boxes. That is very easy to implement, and it gives us the ability to actually step into different types of switches and different radix of switches in a very clean and easy way, because we don't have to wait for a very large 512 ports or 256 ports. We can actually go on the thing that go out first in every industry. It's the one RU top of rack with X number of ports in it. If it's 32 by 100, it's going to be 64 by 100 or 32 by 200. So that's that. From a Open19 perspective, the architecture of Open19 is 48 servers star into a top of rack, which is optimized. I didn't have time, so I didn't talk too much about how we optimized it, but we optimized it from 2 levels. One is we don't have cables anymore in the rack, as you've seen. And the second thing is we can actually uplink from that at very high bandwidth and a relatively low oversubscription on the rack level. Just to give you a little bit of feel of that, on our data centers, when we do bring up, almost 25% of the failures in bring up is actually cables. The technician did not plug it in properly, did not use the right cable, did not label it properly, hooked it up to the wrong port, etc. By doing this, we eliminate all of that. We don't have any more cables in there. And in the process, we also saved about $60 per cable per server in our data center.
Super.
Thank you.
Well, thank you very much, John.